Polynomials in one variable x of degree n is of the form p of x equals an x raised to n plus an minus 1 x raised to n minus 1 plus etc. a1x plus a0, where a0, a1, a2 etc. an are constants and an not equal to 0. Now let's divide the polynomials by a linear monomial. For example, divide the polynomial 2x cubed plus x square plus x by the monomial x. That is, by dividing each term by x and simplifying them, we get 2x square plus x plus 1. So we can write the polynomial as x into 2x square plus x plus 1, which means that x and 2x square plus x plus 1 are factors of the polynomial 2x cube plus x square plus x, or 2x cube plus x square plus x is a multiple of x and 2x square plus x plus 1. Next, let's divide 3x square plus x plus 1 by x. We get 3x plus 1 plus 1 by x. So, the polynomial can be written as 3x square plus x plus 1 equals x into 3x plus 1 plus 1. So, x and 3x plus 1 are not factors of the polynomial as there is a remainder 1. Now, let's go to the next level by dividing the polynomials by a linear binomial. Let's divide the polynomial x plus 3x square plus 1 by 1 plus x. For division by binomial, we need to follow a step-by-step method, which is by long division. The first step is to write the polynomials in their standard form, that is, in their descending order of their degree. So, x plus 3x square plus 1 can be written as 3x square plus x plus 1, and 1 plus x can be written as x plus 1. Divide the polynomial 3x square plus x plus 1 by x plus 1 by long division. For that, first consider the first terms of the dividend and the divisor. If we divide 3x square by x, we get 3x, which is the quotient. So, multiply the first term x plus 1 by 3x to get the product 3x square plus 3x. Now, subtracting those terms with the dividend, we get minus 2x plus 1. Now, repeat the same process, that is, divide minus 2x by x. We get minus 2. So, multiply the divisor x plus 1 by minus 2 to get minus 2x minus 2 and subtract the terms to get 3. So, that is the end of the division, and we can write the polynomial 3x square plus x plus 1 as x plus 1 into 3x minus 2 plus 3. Or in general, we can say that if p of x and g of x be two polynomials such that degree of p of x is greater than or equal to degree of g of x and g of x not equal to 0, then we can find quotient q of x and remainder r of x such that p of x equals g of x into q of x plus r of x, where either r of x equal to 0 or degree of r of x is less than the degree of g of x. Now, let's try to find some link between the remainder r of x and the dividend p of x. We have p of x equals 3x square plus x plus 1 and g of x equals x plus 1, which when divided by long division, we got 3 as the remainder. Now, find the 0 of the polynomial g of x, which is x equals minus 1. Now, substitute this value in p of x, that is p of minus 1. We get p of minus 1 as 3, which is same as the remainder when we divided p of x by the polynomial g of x. This property of the polynomial is called remainder theorem. We can state it as, let p of x be any polynomial of degree greater than or equal to 1, and let a be any real number. If p of x is divided by the linear polynomial x minus a, then the remainder is p of a. Let's prove this. Let p of x be a polynomial with degree greater than or equal to 1. P of x must be divided by g of x equals x minus a to get a quotient q of x and remainder r of x. So, P of x equals x minus a into q of x plus r of x, where either r of x equal to 0 or degree of r of x is less than the degree of g of x. Since g of x equals x minus a is a linear polynomial, its degree is 1, then r of x will have degree 0. So, it is a constant value, say r, that is P of x equals x minus a into q of x plus r. Now, if we give x equal to a, then P of a equals a minus a into q of a plus r, which is equal to r, that is the remainder. Hence proves the theorem. Now, let's use this theorem to solve a problem. Find the remainder when 3x raised to 4 plus x cube minus x plus 1 is divided by x plus 1. So, we have P of x equals 3x raised to 4 plus x cube minus x plus 1 and g of x equals x plus 1. Now, find the 0 of g of x, which is minus 1. So, the remainder will be equal to P of minus 1, and calculating P of minus 1 we get 4, and that's the remainder when we divide P of x by g of x. So, we can conclude that for the division of a polynomial P of x in one variable by a linear polynomial g of x, we can express in the form P of x equals g of x into q of x plus r of x. For division by monomials, the division can be done by simplification, and for division by binomials, we can do it by long division. Also, in order to find the remainder without performing division, we can use the remainder theorem.